when they call us to go do something. That's what we do.
EGS Program Chief Engineer. Verify no constraints to launch.
EGS Chief Engineer team has no constraints.
I copy that. You are clear to launch.
5, 4, 3, 2, 1, and liftoff.
Power clear. Now passing through max Q, maximum dynamic pressure.
Welcome to space.
Welcome to the Rocket Ranch. I'm your host, Joshua Santora. When people think of the Kennedy Space Center, rockets are what likely come to mind. But we have more than rocket scientists here on the Space Coast. We're a bit like a small city. In this episode, we meet a few ranch hands with odd jobs you may not expect to find around these parts. First up, we talk with a marine biologist who actually gets to fish as part of his day job.
Literally the best habitat we have here on Center, and probably just about the best habitat here in the county, is, no joke, a stone's throw outside those launch pads.
Next, we sit down with a driver whose vehicle of choice weighs 6 million pounds and clocks in at a staggering 1 mile an hour.
It has the power, the electrical power to do 2 miles an hour, but you never would do that, right?
Finally, a helicopter pilot who tracks animals and trespassers rounds out our glimpse into odd jobs here at the ranch.
We'll be up in the air during launches, looking for anyone trying to do damage to the rocket or just make themselves famous.
Kennedy Space Center not only launches rockets, but it also doubles as a wildlife refuge. Looking after many of the critters here on the ranch is marine biologist Dr. Eric Ryer. I'm in the booth now with Dr. Eric Ryer. I will call him the fish doctor. Dr. Ryer, thanks for being here.
Sure, yeah, it's my first podcast.
So tell me a little bit about yourself. What's your background? And obviously give some context as to why I would refer to you as the doctor of fishing.
Sure, so I'm a fisheries biologist here at Kennedy Space Center. I've been here now almost 20 years. I was planning on being here for 2, but the place sort of grabbed a hold of me, and it's hard to leave a job this interesting. I'm part of the Kennedy Space Center Ecological Program. It's a group of, I think, about 15 biologists that work on a variety of environmental issues around the Space Center. And so I'm a fisheries biologist here, but we've got marine mammal folks. We've got folks that study endangered species like scrub jays and sea turtles and beach mice. And we cross-collaborate on a number of issues around the Space Center. But yeah, I came down actually from outside of Seattle to go to FIT down there in Melbourne for a couple years, and it's pretty spectacular. In fact, one of the first jobs I ever had coming here wasn't related to fisheries, but when the shuttle would launch, we'd actually, right before launch, we'd go into the pad perimeter. The space shuttle was on the pad, it's getting ready to go. A few days before launch, we'd go in and we'd have to clear out all the baby alligators that had made it under the fence. And baby alligators are really fast. And so there's these ponds that collect deluge water from the shuttle, and these little baby gators could make it under or through the fence, and some turtles too. And we'd have to hop in there, and we'd go in with just an empty truck, and we'd come out with a truck full of baby alligators and turtles, and we do that before every launch.
Can you tell me a little bit about what's going on as far as right around a launch pad, for instance? Because I know that's probably, when we think about if we're harming the environment, people would expect it to be there. So what's the environment like in that area?
Yeah, it's just the opposite. That's an excellent question. We think of rocket launches as really dangerous and very industrial, and clearly they are. But the impact of those launches is, the footprint is very small. And from our observations over the years, literally the best habitat we have here on Center, and probably just about the best habitat here in the county, is, no joke, a stone's throw outside those launch pads. And we've got huge sport fish that come really within the shadow of some of our launch facilities. And it's because there's no other development, but wildlife benefits tremendously from the space program as well. So
yeah, that's awesome. So I want to step back for a second, because obviously you just mentioned a lot of biologists and a lot of interesting wildlife that people may not be familiar with. So we need to paint a picture for what the Kennedy Space Center is, because people say Space Center and they think rockets, they think smoke and fire, they think obviously like big production, but we're surrounded by a wildlife refuge. Can you tell us more about what would people see if they came out here?
Yeah, they'd see a lot of green, to be honest with you. I think it was back in the early 60s, I think 62. NASA needs a lot of space to launch rockets. both for public safety and security purposes. So early 60s, they bought up a lot of property here. And they realized early on that most of it wasn't directly going to be used for rocket launches. The Space Center is actually huge. It's about 140,000 acres, of which, when you do the math, about 5% is actually used for space launch infrastructure.
That
launch
sounds
pads,
about right,
roads, buildings, etc. They fairly quickly ceded a lot of the natural lands management to the U.S. Fish and Wildlife Service, who created Merritt National Wildlife Refuge. And then a little bit later on, the northern part of the property was actually, management was ceded to Canaveral National Seashore as well. So we actually have a wildlife refuge and a national seashore that overlay Kennedy Space Center. Another interesting aspect of it is NASA wants a security perimeter around their launch infrastructure, which makes sense. So early on, they established this perimeter, which there's no public access around these launch pads. And while the purpose was public safety and security, they sort of coincidentally created what we call a de facto marine reserve. And marine reserves, they're being used more and more for marine management, where basically you set areas off limits and let the ecosystem sort of persist in its natural state. And then in some areas are controversial. At the Space Center, they're not, because it wasn't really designed as a marine reserve. It was designed for security. Fish don't know that. So the fish here have been basically unmolested now since 1962. And there's been several studies that have shown that water within the security zone of Kennedy Space Center, they harbor higher densities of sport fish. Those sport fish are generally larger, and we have higher overall fisheries diversity within the Space Center than adjacent public areas that have been developed over the past few decades. And so it's basically a gem here in East Florida. The fisheries habitat here is the best we have really on the East Coast of the United States anymore. On the fishery side, we've got red drum, black drum, spotted sea trout, tarpon, snook, all these really important sport fish. And a large percentage of the rest of that is actually managed in a fairly natural state. So you've got a tremendous amount of habitat and wildlife issues that you have to attend to. The lagoon has a very high density of West Indian manatees, green and loggerhead sea turtles that use the lagoon as basically a nursery as well. Bull sharks is the common fish in the lagoon. Our folks terrestrially work on scrub jays, bald eagles, gopher tortoises, invasive hogs. Most dense population of alligators left in the Indian River Lagoon is here at KSC. Much of the Space Center is actually co-managed, either as Merritt Island National Wildlife Refuge or Canaveral National Seashore. And so NASA, as a federal agency, they're held to sort of a high standard on how they maintain their land and the wildlife that inhabits that land, and that's sort of where we come in.
Cool. And so what is your day job? Like, what do you do on a daily basis? Would we find you in an office? Are you outside, like, hacking through the bush? Like, what's going on?
Oh, so that is the best part of my job, is that it's the diversity. I'm in the field quite a bit, probably about 2 to 3 days a week. But we also do a fair bit of lab work, and like not only do we have to catch fish, but we have to write about it as well, permits and reports and whatnot. But all in all, it's a super diverse project. You don't know what you're going to get into on any given day because issues pop up all the time, and there hasn't been a single day where I rolled out of bed and didn't want to come to work.
That's awesome. That's so cool. So obviously, it's probably no mystery now at this point. Like, it is factual that on some days we pay you to fish. Is that fair?
I'm told I'm not
say?
supposed to advertise that. Yes, but so it's a little bit different. In a way, it's cheating because we get the permits to fish with interesting gear like long lines and gill nets, where you can catch a lot of fish really fast for scientific purposes. But you're also we don't take things home.
Yeah, exactly.
We generally, most of the fisheries research we do, and we can talk a little bit about this in depth later on, is non-lethal. We catch fish, we measure them, record them, identify them, and let them go.
Yeah, I want to make sure that we are clear to say that it's not like you're out here like just sitting back, just chilling in the boat fishing. Like, you're out here, you're doing research, you're doing science. So give us some examples of the research that is going on, both amongst your team as well as I know that we bring in other folks to do research in the area as well.
Yes. Big picture, if you look at the landscape at the Space Center, it's about 65% water. So fish are really a dominant part of the ecosystem here. We've got a number of, in fact, I think about over 100 species that are federally managed, which means that NASA's got to consult with other agencies when they do construction or modify habitat. And so having that basic information on where fish are, what are the most critical habitats around the Space Center, that information is important because it allows NASA to minimize the effects of basically the space program on the fisheries habitat here. So some of the specific projects we do, we're involved in what's called the Florida Atlantic Coast Telemetry Network. It's an an array of now several thousand underwater listening stations, or they're acoustic receivers, but they're moored underwater here in the lagoon and along our shoreline here at Canaveral. And so we manage this section of the fact array, and we're teamed up with all sorts of universities, wildlife agencies, basically from the Gulf of Mexico up to Canada. And these sensors that are underwater listen for the passing of tagged fishes and sea turtles. We put transmitters, typically we actually sew them inside the fish. The sea turtle biologists we work with will fiberglass a transmitter on the sea turtle, and they ping about every 90 seconds. And as these animals move through the environment here in the Indian River Lagoon is what's surrounding the Space Center, or along the Atlantic coast, which is, we border the Atlantic Ocean. As these animals move through the system, we can actually document those movements, their habitat preferences, their survival sometimes using this system.
So why is that important? Because I think that there's some people that are lovers of all things fishing, and they can kind of appreciate what you're doing. But for those that may not really have a background with fish and fishing, like, why does it matter that we track these fish or turtles or the nesting patterns? Like, what does that benefit us?
Sure. So it benefits NASA because now they have a good sense as to, what fish we have here, where they spend most of their time, where they're spawning, where they're foraging. And like I said, many of these are federally managed. By knowing that information, you can actually make good choices on how you develop habitat, or, if possible, avoid critical habitats. You can gauge the effects of construction activities. We have mitigation sites where we actually open up if there's work going on in habitat that needs to be altered. We can actually help restore other areas, and we can document that through this network.
So kind of switching gears,
sure.
Just thinking about cool stuff that you found, because obviously, like,
oh, now we're talking.
The ocean and rivers and waterways are places of, in a lot of ways, great mystery.
Mm-hmm.
Tell us, what have you found that's really cool out there?
Yeah, so that's the most exciting part of my job is, we know so much about terrestrial organisms. We've been, people have known the details of how, for example, birds make their living since, the 50s. They've been able to radio track them across the continent, and fish are different, especially around here. The water is it's so murky. These animals, even really small fish, will migrate potentially hundreds of kilometers. Learning the details of how they make their living in the ocean has been really hard, and we're actually sort of at a golden age in fisheries in terms of technology. The satellite, you can put satellite tags on big sharks that if their fins stick out of the water, they can actually communicate their position and environmental conditions to the satellite, and it just comes into your email. Some of the things we've learned specifically, there's a species called the Atlantic Sturgeon, which is on the U.S. Endangered Species list, which is a big deal for a fish. Historically, we thought they were exceptionally rare in Florida. 3 records in 100 years anywhere off of East Florida. And we detected 12 of them last year. All from, basically, they were tagged by other researchers doing the same thing that we are up there. But as the animals move along the coast, we'll detect them. And then we send that data back to these researchers, but tagged basically from the Carolinas all the way up to New York. Another cool one is, we didn't know this until recently, but white sharks, which we thought were actually fairly uncommon here off of Brevard County.
Right. I feel like this is like
absolutely not the case. They are.
This is like a warning, everybody who's listening, if you live near here.
So white sharks get all the press. They're a little too glamorous, for my taste, but they do capture people's attention, and they're getting tagged all over up in New England.
Sure.
And, there was encounters every now and again of white sharks down here, but it turns out they're actually really common here every winter. They're tickling the feet of the surfers, and people didn't even know it.
So maybe the story there is we were doing well because nobody has really had a problem until just recently when we're starting to realize this.
Yeah, well, they've always been here, I'm sure. So for thousands and thousands of years, they've been making this journey in the winter, and they don't stop here necessarily. They keep going.
That's awesome. So these tags you talk about, I know you mentioned that you're tagging some animals. Obviously, other people are tagging animals. Do people ever find your tagged fish? Do they ever fishing somewhere where it's legal and they catch one of your fish?
Yep. So most of the fish that we tag are legally harvestable, and so and we sew these transmitters about the size of my index finger into the fish, because that's where they'll stay there for years and years, and they don't affect the behavior of the animal at all. But if a fish is harvested and the angler decides he wants to take it home and clean the fish, oftentimes this transmitter will fall out. And we've learned, hey, put your name and phone number on these things, because they're worth about $300, and it's another, if we get it back, we can go tag another fish and increase our data set for sure. And to be honest, I love those interactions with fishermen, because we consider ourselves experts, because we do this for a living, but I spend half my time in front of a computer and talking to these folks, especially the commercial folks and the recreational guides that are around the Space Center. The guides come from all over to fish around the Space Center because the habitat is better than anywhere else here in
Cool.
the Inny River. I learn more in 10 minutes talking to those guys than I do, reading journal articles all day.
That's awesome. Very
Yep.
cool. And obviously we have to ask the question, have you had one that got away? Like, is there the one that got away?
One that got away. No, in fact, just the opposite. The one fish that I always wanted to catch, and I thought I would never have the chance to do it. It's called a small tooth sawfish, which is, I don't know if you've ever seen them. They're actually more closely related to stingrays, but they have this big saw or rostrum that comes off their snout.
Okay.
They get about 18 foot long, and historically they were a dime a dozen here in the Inny River Lagoon. A huge problem for commercial fishermen way back in the 1800s, and they didn't have the ethic that we do now. These sawfish would get into the fisherman's net, and the fishermen would chop the rostrum off, and the sawfish, couldn't survive. And so the sawfish crashed back in the 50s. We never thought we'd see one around here, but back, I think about 2004, we were fishing right off the beach tagging sharks, I think. And it was the very first set of the very first day of the study, and this sawfish came up on the line, and because it was always my dream catch, and I'd always announce today's sawfish day, and it was a joke. And then that first line comes up, and here comes this huge sawfish, and it was spectacular, and it was mad. Oh,
how big was that one?
It was a juvenile. It was about 10 foot long is all.
That's a juvenile, 10 feet long.
Yes, exactly. So
goodness. What's the biggest thing you've ever seen out here?
We have what's called a Longline Survey. It just ended, but we were surveying right off the Cape. So we know what's around, and what's not around is just as important. We lay what are called long lines, which is basically it's a 2,000-foot string of really thick fishing line that's anchored on both ends on the bottom. And every 50 foot you'll clip a hook on it with some bait, and you let it sit for about half an hour, and then you reel it up on a winch. And we get a lot of little stuff. I mean, they're big,
Sure.
4 to 6 foot long sharks are really common. Red drum, if they get about 3-4 feet long. And so sometimes we'll set two if the sites are really close together. So we set one, ran to set the other one. We could still see where we set the first one, we thought. But when we got back to pull it, our long line, and you can tell by there's floats that mark each end. It's nowhere to be seen. And that's really strange. And really, it gets you nervous when you lose a big piece of gear like that. So we're looking around. And
we're going to need a bigger boat?
Yeah. Well, lo and behold, there's our long line floats just hauling offshore. It takes a really, really big animal to do that. And so we caught up to it, and when we caught up to it, realized whatever had snagged it in the middle, and the line had bent around whatever fish was towing it, and all those other fish that were on this long line had now, because it was a really good set, otherwise we caught a bunch of other sharks, and they're all tangled up in this whole mess of long
dragging
line.
behind this thing.
And so we catch up to it. We sort of basically cleat this line off to the boat. It starts to drag the boat as well. And we're working up these sharks, and we want to get the sharks off and measure them and let them go. And it starts to occur to me that what else can this be but a great white shark?
Right.
Because, I mean, it was literally towing our boat. So I start getting excited, and so that like I mentioned before, white sharks get a little too much hype, and so I sort of was like, I play the tough guy, like I don't want to see a white shark, they get too much love. But once I realized we might actually have one, I started getting sort of excited about it. They were saying, Eric, settle down. But I was confident this thing was a white shark. And we finally, after like 2 hours, we caught up to it, and we got right there. This is the grand finale. We're gonna see, and I've never seen a white shark in person. And it turned out it wasn't a white shark. It was a giant manta ray. Which is,
how giant are we talking?
Oh, they get huge. But they're supposed to be here, and it just didn't occur to me that we could have caught a manta ray. And manta rays, they feed on plankton. So what happened? It had just sort of swam into the net, and it got hooked on its fin for a while. And this thing was probably about 15 foot wide. It was a huge animal. So I would actually circle back to your original question. What's the biggest animal you've seen? That's probably it.
Yeah.
But I was, I guess, sort of highly disappointed that it wasn't a white shark. And my coworkers bring it up, not daily, but quite often. They don't let me forget how excited I got about the white shark that I'd been ho-humming for years and years. So,
awesome. Well, Dr. Ryer, I appreciate you coming in.
Okay.
Thanks for being here. I wish you the best of luck. Thanks for taking care of our
this was fun.
environment. Thanks for looking out for us, and happy fishing, happy research, all of the above.
Okay. Thank you very much.
As Kennedy's Exploration Ground Systems ramps up for the first launch of the new Space Launch System rocket, crawler driver Sam Dove with contractor Jacobs puts the behemoth transporter that will take it to the launch pad into gear. All right, I am back in the booth. Today I've got Sam Dove. Sam is a driver of our crawler transporter. So, hey, Sam, thanks for being here today.
You're welcome.
To make sure people understand that this is a pretty massive machine. When we talk about you're a driver of a crawler, that may not sound that large, but we're talking about you can put a professional baseball diamond on top of the crawler. Is that about right?
Yeah, you could fit a baseball diamond on top. That's one of the things that gives everybody an idea, just how big it is.
What is the crawler used for? Why do we need such a large tracked vehicle?
Well, the crawler's used to pick up the mobile launcher,
which currently is a massive platform with a massive tower attached to it, which I think I'm hearing weighs on the order of like 10 to 12 million pounds when it's done, something like that.
Yeah, the rocket is stacked in its entirety on top of the mobile launcher. We pick that whole assembly up. The lifting capacity is about 18 million pounds. We carry it out, take it to the launch pad, set it down on the launch pad. Anything big has to be moved. We move it.
How do you get to the job of driving a crawler transporter?
I worked here for 30 years at Kennedy Space Center. First 10 years in design engineering, and then the last almost 21 on the crawler as an operations engineer.
And you mentioned that was because you're not just a driver.
Right.
You do a lot of different things, and so the engineering comes in with maybe not so much the driving aspect, but some of the other elements. What else do you guys do?
Well, I'm also a certified test conductor. Test conductor's in charge of the operation on the crawler, in charge of all 30 people and everybody you have to have, and all the operations. In charge of keeping things going, keeping the flow going right, making sure the checklists are followed. Also a certified jacking equalization and leveling operator. Engineers usually do those three jobs, and part of that you have to know all the crawler systems, how to repair them, what's got to happen, what's wrong, how to troubleshoot. You have to do any mods on the crawler.
We know dealing with any machinery, nothing works 100% of the time. So can you give me kind of a feel of what are maybe some common issues, or what's maybe like the weirdest thing that's ever happened to the crawler, things that jump out at you?
Most of the time it's well behaved, and we take a lot of pride during our maintenance and everything, but occasionally it is a machine. It might have a roller or a bearing go out, or maybe you have something go wrong with a generator or maybe a transducer. It's never the same, right? I mean, the same thing hardly ever breaks 2 times in a row. We've broken a shoe before, and that single shoe has to be able to carry the whole weight that's pushed down on it through the rollers. Think everybody's pretty familiar with a bulldozer or something like that.
Sure.
You can think of that and just take each one of those pieces of that track and just make it about 20 times bigger, right? and each shoe does weigh 2,000 pounds. So you definitely have to come to a stop for that. And it could be a lot of things. You just have to go troubleshoot the system, go figure out what's wrong, and fix it. Now, we have a lot of redundancy on the crawler as well, so a lot of times you can just shut that down and go to the redundant system and continue on. If you don't have redundancy, then what we have is a big support team behind us, right? When we're rolling, we usually have everybody that we need to call back and say, hey, we need this part out of stock. And those folks, they're great. I mean, they take care of us so good. When it gets there, our techs go change that stuff out, we test it, then back on the road again.
Thinking about something like that, how long are we talking? Like, what kind of a delay is this? Is this like 30 minutes, a couple hours? How are we compared to AAA?
Oh, well, if they had to come tow, AAA would make a fortune, right?
Listen, is there a vehicle big enough to tow a crawler? Because I would love to see that vehicle.
The other crawler.
Yeah, so we call it the crawler, and I think it's with good reason we call it the crawler. Yeah. When you open this thing up and you go full speed ahead, what are we talking about on top speed here?
Well, it has the power, the electrical power to do 2 miles an hour, but you never would do that, right?
So top speed is 2 miles an hour.
Yeah, well, that's what all the specifications say, but we've never. I mean, I've never had it up past 1 1/4,
Okay.
And you just wouldn't want to do that. It's too hard on the equipment, too hard on what you're carrying.
Sure.
And you can accomplish the same thing at a slightly slower speed, and get there with less chance of damaging anything. It just takes you an hour or so longer.
And what's the total time on that trip? Obviously, you're not moving very fast. How far is it, and how long does it take you?
Well, it depends. It's a 4.5 mile trip, usually 7 to 8 hours. But the trip in between, it's everything you have to do to get ready, to get under the load, pick it up, make sure everything's disconnected, pick it up, carry it out, and then do the reverse when you get there, get it set down, make sure everything's hooked up. And the crawler provides a lot of other services to the mobile launcher, a lot of power and things like that. So there's a lot of connections and disconnections have to be done. The whole rollout, it really depends on how things go, but it can run anywhere from 16 to 20 hours.
And so thinking about kind of a day, this day of your work, obviously we don't move the things on the crawler every day.
Right.
So when it is a crawler moving day, what's that day look like for you? Like, how does the shift work? Do you sit in the driver chair the whole time? Walk me through a day.
No, well, typically if we're moving, we have assignments that we sit down, and myself and another engineer make the assignments. Usually you can spend anywhere from 1 to 2 hours driving. And then we switch and rotate around, and then you come and spend 1 to 2 hours operating the leveling system. And if you're certified, then you come to spend 1 to 2 hours as a test conductor. And then other times when you're not scheduled for anything, you're constantly on the move or checking systems to make sure everything's good, make sure we have no problems, and constantly checking with our guys, making sure they're okay, and just generally making sure that the mission's going smooth and the crawler's all right.
And what's it like inside? So thinking about, you're obviously not driving the whole day. You're taking on different tasks. What's it like to be inside? What kind of environment is it?
Okay, the crawler's divided up into sections, believe it or not. You have the cabs where you actually drive.
Too, right?
Yeah, it is. You have the cabs where you actually drive from. There's a console in there, with buttons, switches, dials, meters, and computer screen, of course. And a low-rider type steering wheel. It's a very small steering wheel, but it's all fly-by-wire kind of, right? So you spend some time driving in there. And then inside the control room, which is in the middle of the crawler and on side two, you have all the operations, the consoles, everything for the jacking, equalization, and leveling. You can see the test conductor is in there. And from there, the test conductor can see everything that happens on the crawler. Pressures, temperatures, RPM, what's running, what's not. You've got a camera system where you can see where everybody's at, how things are doing in the engine rooms and the pump rooms. You can see how high we are, how low, how fast we're going, laser docking things, everything like that. What kind of power we're generating, how our generators are doing, and how the computers are working out. Virtually everything you can see on the crawlers in the control room. And then on each end of the crawler, you have an engine room on N3 and one on engine room 1. We have an Alco engine in there connected to 2 DC generators, and then we have a Cummins engine in there connected to an AC generator that provides all our AC power. And then in the middle, the very middle, we have our pump room, which has our jacking, equalization, and leveling system, motors and pumps, and the steering system, motors and pumps, and all the superchargers and things like that you have to run the pressure up. And you have about a 22 or 2,300 gallon hydraulic tank in the middle that holds all the hydraulic fuel. And then on the opposite end, you have the same configuration of the engines again, except they're just kind of mirrored over. You have an Alco engine on that end and another Cummins engine.
Do you know what the fuel efficiency of the crawler is? Any idea?
Sometimes, the Cummins engines, when they're carrying a lot of electrical load, you use 35 gallons an hour just on those. And you might see somewhere around 90 gallons or say 75 to 90 on the Alco engines, depending on the load and how hard you're running.
How long have we been using these crawlers for now?
Since day one of it started with the Apollo program, and that was one of the main concerns of the Apollo program. Could the crawler actually carry a Saturn V rocket in a tower, right? Which was, you think back to 1963, 64, 65, even 66, it was still an unknown, and it was a question whether that could happen, but the guys who designed it they knew what they were doing. Did a real good job with it, made a few modifications here and there, and it's been able to carry every rocket we've had since Saturn V through the shuttle and now up to Space Launch System.
So we're traveling to the launch pad. What are we driving on? Is this just concrete? Is this a normal road? What is the structure like that you travel on?
Right. The crawlerway it's the size of an interstate, a modern day interstate, right?
Like a full interstate, right? Not just like a full interstate lane. It's a full width interstate.
Right, full width interstate, 2 lanes on each side and a median in the middle. Originally, they had planned to put down asphalt the entire way, but as it turns out, 12 to 16 million pounds, in this case 18 million, crushes asphalt up pretty good. And when you try to turn, it kind of hooves it up a lot. So what they found out was that the best thing for the crawler to have is a limestone base with about 8 to 12 inches of gravel on top of that. And so the crawler rides down the crawlerway on this cushion of gravel. It also helps with the coefficient of friction to turn. And it smooths the ride out a little bit, but it makes it easier on what you're carrying as well.
Just to kind of paint a picture for people, if you drive past the crawlerway, if you drive alongside it, it looks like, at high speeds, it looks like tiny pebbles basically filling the crawlerway. So why are we using what we're using there?
Okay, think of the gravel on a crawlerway as like the creek gravel you put in your flower beds at home, right?
Okay.
Only bigger. Way bigger. They're not the small pebbles you have, but it's the same texture, same color. They have the same roundness to them. It's just larger gravel, right? And they use that to fill the crawlerway. The crawler rides on it. The crawler doesn't have a suspension, so that helps out with the smoothness of the ride, also with the turning and everything. And it helps. It's easier to groom that type of gravel too, to keep the crawlerway conditioned and fit. And it makes it a lot easier for the crawler leveling system to keep everything level and equal.
So thinking about leveling, when you get out to the launch pad, you're actually driving up a mound. If people have seen images of that, you know that it's definitely an elevated structure there.
Right.
So are we tipping our rocket over as we ride up the hill?
No, not at all. The crawler keeps everything within a couple of inches, right? Keeps it level and equal from end to end, side to side, and across. If you think of the crawler having an X across of it, it keeps it level and equal across there. And as you go up the pad surface on the slope, the front end comes down as low as it can go, and the back end will rise up as high as it can go to its limits. And that way it keeps it very level as you go up and gives it a smooth ride. And as we reach the top of the pad, everything jacks back down and gets it level and equal again. And then we go over the mounts and we set it all down.
Cool. Clearly this is a hulking machine, but how finite is the control? Because once we get up to the launch pad, I think you got to park it in a pretty specific spot, right?
We do. Yeah, hulking makes it sound. It's like it's pretty much of the crawler. I can make the crawler go so slow you can barely tell it's moving, or we can go up, to the fastest speed that they'll let us go, 0.8, 0.9, 1 mile an hour. But it does it, and it will speed up and slow down in a very nice manner. And you have to remember, this is not all computer controlled. The driver controls it. And once our drivers get proficient, you can speed up and slow down in such a nice manner that the instrumentation, some of the instrumentation guys that are watching are like, wow, that almost looks like a computer did it. And you can steer, and you can get this thing, you can set that mobile launcher down. Right now, in the shuttle program, we were held to a 2-inch circle, right, to set the mobile launch down. And the mobile launcher has 6 guide pins that stick down. And these guide pins are they're a good foot across, probably 18 inches long. And you have to put those down on top of the mounts to fit them in the holes. And we can set that down in the shuttle program. Again, they allowed us 2 inches, a circle of 1 inch each way. Well, with SLS, it's 1 inch. Right. So it makes it a little harder. But we can set that down, and with the crawler, you can get it right up in there, and you could set that thing down left or right, a 1 inch, or back and forwards, depending on which you're going north or south. But you can set that down within that 1 inch circle, and you can repeat that virtually every time.
Awesome.
Yeah.
We're talking about a vehicle that travels on a very special driveway, probably has pretty unique and specialized parking spaces. Have you ever run into problems getting in somebody else's way? No.
It was a number of years ago. One of the security guards out here decided it would make a great joke, which to us was pretty funny. I don't know. But we parked in a place we don't normally park, just sometimes you leave the crawler on the crawlerway overnight or whatever, and sometimes at the midfield park site, and sometimes you might be at one of the refurb sites, wherever. And so they left a warning on the side of the windshield right on the door and said, hey, you guys are parked in the wrong spot.
Hey, Sam, I appreciate you coming in today. Thank you for you and your team's work. Obviously, if we don't get to the launch pad, we can't fly. So you guys are a huge part of what we do here, and thanks for coming.
I really appreciate it. And the crawler crew, they're 100% behind what we're doing. Those guys, we have very little turnover. Those guys really stick to their job. They make sure everything works. basically, when they call us to go do something, that's what we do.
So far, we've covered land and sea. Now to the air. Keeping an eye on the ranch from up above is helicopter pilot Dave Ramsey. All right, I'm in the booth this morning with Dave Ramsey, who has the extraordinary task of flying helicopters for us here at the Kennedy Space Center. Dave, good morning.
Good morning.
And tell me a little bit about yourself, kind of your background, how you got here, and what you do for KSC.
Well, I'm Dave Ramsey. I'm the Chief of Flight Operations here at Kennedy Space Center. My day in and day out job is to be a helicopter pilot and manage the aviation assets here on KSC. So that means I get to fly our helicopters and work with our drone guys to make sure we're giving you guys the products you need.
So obviously people know what desk jobs are like, but people don't know what the job of a helicopter pilot really looks like. So what do you do when you're in the air? Are you just flying around, checking things out? What's going on?
So here at Kennedy, so we use the helicopters for a number of purposes. Primarily, we are security. We're flying around making sure people aren't doing things in places that they shouldn't be, or aren't in places they shouldn't be. Looking for fishermen or hunters who are doing poaching game or in the wrong areas inadvertently. So that's the primary mission that we do. We also support our biological guys here, our bioresearch guys, who keep kind of their fingers on the health of the wildlife community here. So counting birds, counting manatees, looking at eagles every year, hatchlings, those types of things, making sure that or just recording the populations and seeing growth or identifying trends. We help with that. And then, as we talked about earlier, those videos for if you want a beach erosion video and you want to see after a storm, for example, what the impacts were, we take teams up to video and document and just check out the center to make sure after a hurricane. We always take Mr. Cabana up so he can fly over the center to get a good feel for the safety and when to bring people back and that type of stuff.
So you've mentioned a couple times people being in places they shouldn't or other things of that nature. Do you all find people out here a lot? Obviously, we're in the middle of a pretty big green area, a national wildlife refuge. Do you find people or things that shouldn't be here?
Yeah, I mean, more than you would think, and it's a lot of times fishermen just in places they shouldn't be, or we've had people picking the saw palmetto berries from the wildlife refuge, which isn't allowed, so we've had to run those guys off and detain people for that sort of stuff. So yeah, I mean, most of it is just people not knowing. So we just, as politely as we can from the air, ask them to move along, honk our horn at them and tell them to get moving.
So what do you do when it comes to launch time? I know that we use our aircraft for security and other things, but how are you involved with launches?
Yeah, so as we get back to crewed flight, we're ramping up now. We're doing some exercises now for a couple of things. Astronaut support, or escort, we'll do that again, which has been done previously. Security of the air during those flights. So we will be ready to respond again. We'll be up in the air during launches, looking for anyone trying to do damage to the rocket or just make themselves famous. So we look for those kinds of things. People coming into the airspace that's restricted during those launches is a good indicator that maybe someone's not paying attention, or they're out to do something bad. And so we do those two things, and we also do the medevac, CASEVAC, in case there is something, if something goes wrong and prior to launch or during launch, we are ready. We have one aircraft standing by to be a CASEVAC aircraft to help move personnel to the Trauma 1 centers or wherever directed, basically. Once when we departed the SLF, there was just as we were departing, there was an anomaly on one of the pads a couple of years ago. We had just departed the SLF and we were flying towards the beach, flying right for that pad when it exploded. Thinking about that has to be my mind couldn't process what was going on at the time. I was like, why is there a fire burning right there? What is that about? But the explosion, obviously people remember how the noise, and so all of our team thought that we had just departed. So they thought that maybe we'd crashed, and that was an explosion. Was our helicopter? So everyone was kind of on high alert during that for a number. No one knew what was going on, just like here on center as well, I'm sure. But
in situations like that and others, do you all take on or have training for supporting kind of fires or other like extreme situations like that?
So what we do have Bambi buckets, which are firefighting buckets that hang under the aircraft that we can put water on things. It's not a primary mission we do, but we can support that. Obviously, in that situation, that's not appropriate. But what we did in that situation is just we picked up our local fire team, fire chief here, flew them over the scene so then they could talk to the guys on the ground. We actually landed and picked up the on-scene commander, got him into the air so he could look at, what was going on, where the fires were, passageways to get to the pad, those types of things. So we do provide that. It minimizes the risk for those guys, those first responders that have to go in, if they can get a safer look from the air before their ground guys have to go in. And then later we brought the drones in. Mike Downs and his crew brought the drones in to fly again that same route and live stream it to the convoy commander's team or they're on the ground so they could get a look and figure out kind of what their plan of attack would be to get their people in there. So it was a good coordination effort between all the aviation assets here on Kennedy to help out the Air Force as well.
Yeah, and I want to make sure to be clear that nobody was injured in that incident. Obviously not a great day for losing a rocket and a spacecraft, but there were no people injured that day, which was great. And pretty early on for your time here, right? So that that had to be a little bit stress-inducing, like, hey, like I'm not very long on the job here, and I'm dealing with a serious issue like this.
Yeah, I mean, in those times, everybody just wants to help, So, but you don't want to get in the way. But we do believe that having that platform, having an aerial platform here on the center, gives you the ability to see the things during those times and really provide insight that can guide those responding personnel, keep them safe, and keep everyone safe. So I think it's nice to be a part of that team that can provide answers when things get a little crazy.
So, Dave, how are you guys involved with the wildlife that is out here? I know that there's a big effort there. Obviously, again, because it is a wildlife refuge, that the view from the sky is very helpful in a lot of ways. So how are you guys involved with that?
Yeah, so we do a lot of overflights of like Mosquito Lagoon and the rivers. It's hard to count manatee from any other way, than looking down on them from the water. So we'll take the guys up and fly so they can count and get routine counts to see what the population's doing, when they're migrating, those types of things. So we do that at least once a month. We'll take the guys up for a couple hours and fly pre-patterned routes that we fly every time. It's the exact route we fly every time, just to try to keep a consistent count going, so they can form those trends and see what's going on with the health of the wildlife.
Dave, appreciate you being here this morning. Good luck out there. Be safe, and thanks for all you do for us.
Yeah, awesome. Thanks.
Clearly, we need more than just rocket scientists to get the job done. Maybe your path will lead you here to join our rowdy band of pioneers. I'm Joshua Santora, and that's our show. Thanks for stopping by the Rocket Ranch. And special thanks to our guests, fisherman Dr. Eric Ryer, crawler driver Sam Dove, and helicopter pilot Dave Ramsey. To learn more about all the cool things going on at the Kennedy Space Center, go to nasa.gov/Kennedy. There are also several NASA podcasts you can check out to learn more about what's happening at all of our centers at nasa.gov/podcasts. A special shout out to my colleague, Laura Aguiar, to our producer, John Sackman, our soundman, Lauren Maythree, editor, Michelle Stone, and our production manager, Amanda Griffin. And remember, on the Rocket Ranch, even the sky isn't the limit.